Good morning. I am Dr. Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad. I feel immense pleasure to be here again for the course Aircraft Stability and Control. Today my lecture number is 28 and I am going to discuss about aircraft equations of motion. In the previous two classes, I have discussed about a very simple case of point mass equation of motion. In that, I have derived the equation for a point mass case. In that, I have assumed that the body is rigid. There is no angle of attack variation. So there is no lift, only drag force is acting. And this drag force, when we have to use, and this will give the acceleration dv by dt, and also the rate of change of flight path, that is d gamma by dt, it is gamma dot. Also we got the equation for x direction, it is dx by dt, and also equation for y direction, it is dy by dt. This we have derived for a very simple case, and slowly we are going ahead, and it will be very interesting to understand dynamics, so that we should be very much thorough about the equation of motion. In the previous class, I have derived the equations for CMQ. The CMQ is a damping function for the aircraft system, especially for when you Q for the longitudinal stability case. So Q is a pitch rate. So once you give the rate, any rate is a time function. So that time is involved. So here dynamics has started. So in this today's class, I am going to discuss about this about difference forces acting on aircraft, then body frame and inertial frame. Then I will discuss about linear momentum, angular momentum. This lecture will also answer the following questions. What is frame of reference? How frame of reference is used to derive the equation of motion? These topics I am going to cover. So just I will start with a very aircraft equation of motion, and it's neat. We have made a beginning with point mass system with a simple approximations like the artillery cells. They fly at angle of attack alpha 0. The force only drag is assumed to be experienced. So only drag force D, and their coefficients is called the CD, or CD naught is only considered. Here we don't consider any induced drag. So if I disturb the airplane, how the aircraft is responding? Do we need to develop complete 6 degree of equation of motion? We assume the rigid body of aircraft. The rigid body means the distance between two particles remain fixed in any condition of the aircraft. Here we have the three axes. This is the body axis here, x-axis, y-axis and z-axis. We are allowing x as fuselage reference axis, and it is a body fixed axis, means with airplane, this axis which is shown in this diagram along with this CG moves with the body. So your x, y and z, all the axes will also move with the body. So now let us define the another axis system called the earth axis system, and that is also called, we can call as a inertial frame, because Newton's laws are only applicable for inertial reference frame. So what is the inertial reference frame? The reference frame in which there is no acceleration. It is absolutely no acceleration, then we can say that it is a inertial reference frame. Okay, we are assuming here Earth as a inertial reference frame because the rotational velocity of the Earth is very, very less compared to the rotational velocity of aircraft. So we assume that the Earth rotational velocity is negligible when we compare with aircraft. So here it is assumption that Earth is inertial reference frame. So here inertial frame of Earth frame of reference. Okay, it is inertial frame or Earth frame of reference. So aircraft will have different forces, and on airplane these are the aerodynamic forces, and these aerodynamic forces are defined with relative motion with air. Next force which is very prominent is a gravitational force, and it is a weight of the aircraft, and it is also denoted as a W or mg. Next force which is propulsive force, which is thrust force. It is also called thrust force, and this is called the weight or W or mg. These things are, and here aerodynamic force, lift, drag. These are the aerodynamic forces which are generated on the aircraft. So this aerodynamic forces depends on the relative motion of the wind. Okay, so it has a zero velocity and wind blow, then it will be generated lot of lift and drag. Okay, so this you can see here, it is xe. We have shown here, it is E stand for the Earth system, and here it is xe, ye and the ze. You can see that one case when aircraft is moving with a velocity v in a free atmosphere. Second case, this is the wind tunnel. Here this is the wind tunnel, and in this wind tunnel, if we fix the aircraft with the wind tunnel and we blow the air from some outside resources by the fan or anything, so this will also give the same, it will generate the aerodynamic forces. So aerodynamic forces are relative to the wind. It is not that if aircraft is only flying, then only you will get lift. If you can fix inside the wind tunnel and blow the air, aircraft will get lift, aircraft will get drag. Okay, so these things we should understand. And this gravitational force is variation with the g. It is depend upon the g, and this propulsive force will be developed by piston, propeller, jet engine, etc., and it will act on the center of mass. So stability, these forces are not considered in moment taken for the CG. Okay, so because these all forces are considered from the center of gravity, so we are taking the moment from the center of gravity, so other forces are not very much prominent. Okay, but aerodynamic forces are very much prominent. Okay, so now we have to see equation of motion of aircraft. We know that by the Newton's second law, F is equal to ma. This F is equal to ma, or A is equal to F by m. It applies that force F on a mass m, so acceleration will be generated at inertial frame. This is very important. We have to understand that these things are in inertial frame. Newton's law is applicable in inertial frame. So if you apply a force on mass m, this mass m will experience an acceleration, and this acceleration which is generated is measured in inertial frame. So we should know what is that inertial frame. Inertial frame should have no acceleration. That is the definition of inertial frame. Inertial frame should not have any acceleration. So if you take here, this is the aircraft. This aircraft has got, this is the CG of the aircraft, and here is XB. It is a body axis, X-axis, body axis YB, and this is a ZB. So it is inertial frame or not? Can we take this as a inertial frame? That is the issue. So since body is moving will have a linear as well as rotational acceleration. So it is non-rotation. So it is a non-inertial or it is a rotating frame. So here this body axis is a rotating frame or non-inertial frame. Okay, so this we have to take that the aircraft, when it is flying, the axis which is on the center of gravity of this aircraft is not the inertial frame, because the axis of these aircrafts are moving and also rotating. So here the acceleration A is equal to F by m should be in the inertial frame, because Newton's law is not for the body frame, it is only for the inertial frame. So how to apply Newton's law in body frame? This is the question. So how we can apply Newton's law? So there is a safe assumption for airplane motion, that is angular motion of earth can be neglected, then aircraft performance in earth is inertial frame of the reference. We can see that we can take the assumption that the angular motion of the earth is very, very less compared to the angular motion of the aircraft. So earth motion we can take as a inertial frame of reference. So again, revisit the Newton's law. This acceleration is equal to F by m, or F is equal to m, F is equal to d by dt mv in inertial frame. It is in inertial frame where mv is a linear momentum. What is the change of linear momentum? We need to think as philosophical way that quantities of the motion contains in a body. So if you take that F is equal to m dv by dt plus v dm by dt. So this dm by dt is a rate of change of mass. So if we are assuming 0, we assume that dm by dt is equal to 0 as there is no change in mass, that is dm dot is equal to 0. Okay. So here, because here we assume that fuel consumption is negligible or very instant of time, a fraction of second, we assume that fuel is constant. The consumption of fuel is constant. So m dot is equal to 0. So this second parameters we have made as a 0. So now this force F is equal to m dv by dt, it is in inertial frame. Okay, but aircraft is in a body frame of reference. So how to convert? That is the issue. So that is the basic 6 degree of freedom equation of motion will be used. So here degree of freedom, we will develop equation of motion, how airplane changes in space. So that is our objective, and in the next few classes we are going to discuss how to develop equation of motion for aircraft in 6 degree of freedom. Now some basic parameters which will be used in our next classes I am going to discuss here and today. So here angular momentum and moment. So body fixed axis system problem is, it is not the inertial frame. So Newton's law cannot be applied correctly and directly. Okay. So we have to change. So here m bar or moment is equal to d by dt h bar, where h bar is a angular momentum. Okay, where h bar is angular momentum, and this h bar is equal to r bar cross mv. So this is called moment of momentum. Just you can see here, if any body is moving with velocity v and it has got mass m, so the momentum of this linear momentum of this body is mv bar. But from here it is rotating with respect to this, and the distance from here to here is r bar. So the net momentum, net angular momentum will be r cross mv. Okay, so this is called h bar or angular momentum. But by this we can get the linear acceleration and the angular acceleration by these two. When we want to find aerodynamic forces, then it is depend on the relative velocity. Just you can see here, if you want to find the aerodynamic forces like lift and drag, then it is with the relative velocity. So here we have to take the this body fixed axis system. Okay, so body axis system is useful in this case. So how to solve dv by dt in body fixed axis system? So here this dv by dt which is there in body fixed system, how to solve? This is the problem which we have to undertake. Okay, now what is the Newtonian frame of reference? And just you can see here that this is a Newtonian inertial reference frame. It is an unaccelerated Cartesian frame. Origin reference to the inertial non-moving frame. Okay, so here this you can see that it is origin and it is not moving, and here x, y and z, and particle is moving in this direction. So you will have, this is the inertial origin, and here I, j, k, this is the earth system. So this you can see that frame cannot rotate with respect to the inertial origin. So this frame will remain constant position, 3 dimensions. What is a non-moving frame? Okay, so translation changes the position of an object. So the inertial Newton's frame is non-rotating frame. Okay, so here we can see this velocity, how this velocity we can represent velocity of a particle. So here v is equal to dx by dt. Here all this dark are the vectors. Here v is a vector, this x is a vector. So v is equal to dx by dt is equal to x dot, and here this x dot is a in 3 component in x, y and z direction, x dot, y dot, z dot. We can also write this x dot as a vx in the velocity in x direction, velocity in y direction and velocity in z direction. Now we can see that linear momentum of a particle, this is represented by p is equal to mv. So here m and v we can write here from here vx, vy and vz here, and this is this system is shown here. So here m is a mass of a particle and vx, vy, vz is a velocity in x, y and z direction. Few important things we have to understand, and we have to see that these non-dimensional and these things variables we have to see here, non-dimensional aerodynamic coefficients, because we use always aerodynamic coefficient. If you see here that body axis frame and wind axis frame. So body axis frame means when the aircraft is, the center of gravity is inside the aircraft. So here we can see that cx, cy and cz, they are the in body frame, and cx indicate that axial force coefficient, cy indicates side force coefficients, and cz indicates normal force coefficients. If you take this thing in wind axis frame, means once you are wind axis, we have to get in x direction, we will get the cd, it is a drag coefficient. cy, it is side force coefficient. This body axis cy and the wind axis cy will remain same because it is not rotating, and the cz in body axis will be cl in lift coefficient. Okay, so it is opposite to the weight of the body. So here we know that functions of the flight condition, that is the control setting and disturbances like alpha, this delta m and delta e, and non-dimensional coefficients allow application of sub-scale model wind tunnel data to full-scale airplane. That is very important parameters. This you have to understand that why we study the this non-dimensional coefficient like CD, CY and CL, because these results can be directly applied to a small model to a bigger model, so that it will be very useful for each and everyone, all the scientific community, to have always the coefficients, So it will be directly applied for different types of aircraft with the same results. Here we have another thing which is called the longitudinal variables. There we have to see in longitudinal case what are the variables. So you can see that here is a x, this is the angle of attack with the relative velocity of the aircraft, and here is the theta, and here is the gamma. This is the thrust force, here is the lift force, and here is the pitching moment, and here it will act the drag force. Drag force will be opposite to the relative velocity of the aircraft. So these are the parameters. First parameter is u, it is axial velocity. Then w is a normal velocity, v is a velocity magnitude, alpha t is angle of attack, gamma t is flight path angle. You can see here, this is the gamma here, this is the flight path angle, this is the angle of attack, okay, and theta t is a pitch angle. You can see from horizontal, or this from the x, from the horizontal to the motion of the aircraft, this is the u, this is called the theta, and theta is called the pitch angle. So alpha is not equal to theta, okay. So this alpha is angle of attack and theta is a pitch angle. Pitch angle is measured from the horizontal axis of the, or horizontal plane, that is called xy plane of the aircraft, okay. So this is the difference. So here this gamma, here this gamma is equal to theta minus alpha with wing tip level, okay. So like this we have to understand the longitudinal variables. Now I will go a little about the Newton's laws of motion, because in the next classes we will be discussing about Newton's laws of motion. So here the first law we have to this thing: if no force act on a particle, it remains at rest or continues to move in a straight line at a constant velocity as observed in the inertial reference frame. So here we can write that momentum is conserved. The first law is what? It is a conservation of momentum. So here d by dt mv is equal to 0, or mv t1 is equal to mv t2. So this is the first law. So first law is a conservation of momentum. The second law here, this you can see that particle of fixed mass acted upon the force. If the mass m is there, if mass m fixed is there and you apply a force F, then what will happen? It will changes the velocity with acceleration. So if you apply a force, this is the mass, and you apply a force F in the mass m, then acceleration will be generated, or the velocity, change in velocity will be experienced. So change velocity with acceleration proportional to and in the direction of the force. You can see here I have shown it will be in the proportional of the force. So force is directly proportional to A, and direction of this and this will be in the same direction. And we can also define the mass. Mass is the ratio of force to acceleration. So m is equal to F by A. So this is the F is equal to ma, or d by dt mv is equal to m dv by dt is equal to F. So here F is equal to Fx, Fy and Fz. In all the three axes we have to take. Or dv by dt, this is acceleration, is equal to 1 by mf, or is equal to 1 by mi, where F is equal to 1 by m in this, and Fx, Fy and Fz. Okay, so like this is the Newton's second law which we have described. So this Newton's second law, this defines the force and acceleration for the given mass. Now this third law, for every action there is an equal and opposite reaction. This is the third law, and you can see here that this is a rocket, and inside we have given the some combustion, and this is moving gases are moving in this direction, so body will move in this direction. So force on the rocket is equal to force on the exhaust gases. So this exhaust gases which are moving out will hit and it will give reaction, and your rocket will move in this direction. When gases are moving in this direction, your rocket will move in this direction. So that is the action and reaction for the Newton's third law. So these three laws we should have very good concept. We should try to understand in the real sense and the physics behind this. Don't only just repeat. If I ask the question, what is the Newton's law, Newton's second law, people will say F is equal to me. Not like this. You should tell the physics behind that. Newton's first law, very few people they will be able to speak. Okay, however, for the Newton's third law, all are very much aware and they can explain very easily. But Newton's first law is very rare, and then Newton's second law describing is not so easy task. Okay, so we have to understand these laws very well before we proceed ahead. Now I have given some important topics here. These are the position and the velocity. Now this force vector Ft is equal to summation Fx, Fy and Fz in time t. So this forces will be force of gravity, force of aerodynamics plus force of thrust. Okay, so we can write that this is the weight plus this is the aerodynamic force Fa plus Ft. I will be denoting like this. So now rate of change of velocity, we can write that dv by dt, rate of change of velocity, as a v as a vector, it is a v dot, and this v dot is a three component, v dot in x direction, v dot in y direction, and v dot in z direction. This we can write v dot is the acceleration, and this acceleration is equal to 1 by mf. So here this m we can write in this matrix form, and f we can write fx, fy and fc. Okay, so in this way we can express these parameters. Now rate of change of position. If r is a position, so dr by dt, here r dot, it is a angular velocity here, and so here x dot, y dot and z dot t, and this is called the velocity v, and this velocity has got vx, vy and vz with respect to the time t. Okay, so these things are position and the velocity, force, acceleration and the change in position or the velocity, force, acceleration and velocity, it is explained. Now we can also express these things in aerodynamic concept, where we have to use the earth reference frame, body reference frame and the wind axis frame. So this we can see that if here Ft is equal to x, y, z, it is an earth frame. We can write is equal to x axis, it is cx, cy, cz in earth axis system, and half rho v square s. Okay, if you make this half rho v square, this force, this will become coefficient of force. Okay, so okay, that we have to consider. So here cx, cy, cz, and this half rho v square we can write as a q bar, and q bar is a dynamic pressure. Dynamic pressure. Okay, and s is the area of wing. Okay, so it is in a earth reference frame. Now this same thing in body axis system, if you write fb, it is cx, cy and cz in body, and to q bar s, and q bar is same, s is same. Now if these forces we have to write in wind axis system. Wind axis system means what? The x of body, this is the x of body, and this is the velocity v infinity, both are in the same line. If it is like this, then there will be a cd, and this cd is a coefficient of drag, and this cy is a coefficient of side force, and cl is a coefficient of lift. This coefficient of lift multiplied by q bar s it will become lift. So lift is equal to CL Q S. D is equal to CD Q bar S. Like this, CY is equal to this side force is equal to this side force is equal to CY Q bar S. So like this we can write, and we should understand these coefficients and these differences in these parameters. We should try to understand, then only it will be useful for us. Okay, so this I have already, I think, discussed this longitudinal variables. This I have already completed in my last slide. This you can see here, lateral and directional variable. So we know that we can divide our these motions in two groups. One is a longitudinal variables and another is a lateral and directional variables. So we have discussed a lot about that. So in longitudinal variables we have U, W, this V, alpha, gamma and theta. But here we have beta. Beta is a side slip angle, psi is a yaw angle, zeta is a heading angle, and phi is a roll angle. So these angles, if you see here, this is the beta. Beta is a side slip angle here, and here this is the zeta, and here is the phi is a roll angle. The roll angle is the angle between the vertical and in the perpendicular to this axis, rolling moment perpendicular to this axis. Okay, here you will generate a side force in this, and this is the yaw moment in this direction. Okay, so here it is a psi, it is a beta, and it is a zeta. So here you can see that this zeta or heading angle is the summation of the this yaw angle plus the side slip angle. Okay, so this zeta here, this is equal to summation of psi plus beta. Okay, so these are the variables in. So this is beta is the angle between the center line and the direction of flight. Psi or yaw angle is the angle between the center line and the local horizontal. This zeta is angle between the direction of the flight and the compass reference, that is the north. Okay, this we have to, from the north we have to see, and this phi is the angle between true vertical and the body z axis. True vertical and body z axis. So this I have explained, and in next class I am going to discuss about the 6 degree of freedom equation of motion, conservation of linear momentum equation, conservation of angular momentum equations, rolling, pitching and yawing moment. These topics I am going to cover in my next lecture. Please be with this and try to tune in for my next class. See you soon for the next class. Okay, thank you very much for joining this class. My references are this: Robert C. Nelson, Aircraft Stability and Automatic Control. Then NPTEL lecture of Aircraft Stability and Control by Professor A.K. Ghosh, IIT Kanpur. I am referring this website, and I am again thanking you all for joining this class. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.